Hello everyone, and today we'll be seeing one of the problem from Leetcode, and this is a good problem. It says binary prefix divisible by 5. So here we are given a binary array nums, which is 0 indexed of course. We define xi as a number whose binary representation is a subarray of 0 to I. So from the most significant bit to least significant bit. That means, for example, if you have nums as this array, then x of 0 means this 1, then x of 1 means 1 0 means it is meaning the 2, because the binary representation of 1 0 is 2, and x of 2 means 1 0 1, which means 5, because 1 0 1 in binary is 5. We need to return an array of booleans, which would be the answer, where answer of I is true if xi is divisible by 5. So for this example, answer would be false, false and true, because the first two are not divisible by 5 and the last one is divisible. Similar goes here, 0 is divisible, 0 1 is not, because 0 1 is 1, and 0 1 1 is also not, because 1 1 or 0 1 1 is 3. And similar goes with this, 1 is not divisible, neither 3 is divisible, and neither I don't know, like, what is this, 7? Yeah, 7 is also not divisible. So the problem is straightforward at first instance, but there is a hidden problem upon it. If you can go ahead and just do a direct conversion based upon your array from 0 to I, it would throw you an error. Direct conversion gives error. So why does it give an error? Because eventually you will hit the limit. As you can see that it's a binary system, so you'll have number from 0 or 1, but this 1 0 then again 0 then again 1, it would go ahead till at max 32. Why 32 so? Because let's say integer limit is 4 byte, which means 32 bits, and each bit we can store only 32, but here we are bombarded with not 32 but 10 to power 5. So length would be not just 32 but 10 to power 5, and in this situation not only end but long as well fails. And obviously just don't go ahead with big integers and all those things. Those are just those would just hamper the logic and slow down the entire system. Can we do better? Yes, obviously we can do better. It's good that we have identified the problem first of all, and it's better we can go ahead. So how can we deal with this? You see, these are just a binaries, 0 1 0 1, which are keep coming in. So to create a number is not a big deal. Create a number from the string is not big deal. The deal is to also identify whether it is divisible by 5 or not. So how can you know that if it is divisible by 5? So you need to know that 0 5 10 15 20, these are divisible by 5. So that means you have a gap of 5. So from 0 to 5 you need, from 5 to 10 you need to work upon if it is on 5, or if it is the number is upon 10 or the number is upon 5, you are on the safer side. Same goes with 10 15, and you got the drill how I am going ahead. So idea behind is to understand where does the number lies where from 0 to 5. So if you got to know that, then we are good to go. Even if I have some number like 1000, and if I modulate with 5, I know it lies on 0, then I'm a spot on. That's very good thing. or if I have a number like 104 which is mod by 5 which is 4, which unfortunately is not a number for us. Mod, if 105 mod 5 is 0, then it's true for us. So likewise we'll go. So we have two things: not to store the direct number and keep checking just between 5. So if I don't want to store the direct number, I need to go ahead and use the number or create the number on the fly. So if I'm having something like 1 and I wanted to add 10, just like within our problem, I need to shift out the 1 with one position. So this one is just a position, and then I'll get a next character which is 0. Now in the next example, we know that 1 0 next character is 1, and we have from the earlier thing as 10. No, it's not 10, it's 1 0. We'll shift it by 1, which means we are creating a room for another thing, and here also we are creating a room for another thing, which means 1 and the room. This is the room, and I will add this number. I will just add this number in the sense of I will take the upcoming number, which is 1 here, and just insert into the empty space 0 1 0, which means 5, and it is divisible. And like this way I'll not create a direct number, but I will understand how the number is flowing. And to keep checking just between 5, we have a good modulo operation that we can just go ahead and take a number. If I wanted to keep between 0 to 5, then a number should be modded with 5. So either it will be 0 to 5, 0 inclusive, 5 exclusive. So you will exclude 5 and not include it. So in such a way, there is one beautiful way to tackle this problem. And with this keeping in mind, let's go ahead and solve this. Okay, this site has been responsive. Okay, so let's solve this by including these two things. I'll just zoom in the code a bit more, zooming in. Yeah. So first of all, let's create a boolean array, because that's what we are going to return. Boolean result is equal to new boolean new array list. I'll say I'll have a running number which initially would be 0, and I'll iterate upon number from nums. Now let's create a number. Let's include this running number with this method. We are not storing the number directly, we are just taking the current bit and understand the running number. So running number is equal to running number left shift by 1, which we are doing the left shift, which will create a 1 space for the upcoming bit. And the upcoming bit, it's better to give it a name as bit would be more interesting. So this is how I'll create a new number. And to understand that this new number is not going beyond 5, what I'll do is I'll take this running number and mod it with 5. And if this running number is equal to 0, which it can be because I'm modding with 5, so it can be 5 and 5 mod 5 was 0. So if that is the case, then I would just go ahead and result dot add true, or just wait a minute. So I'll just result dot add running number is equal to 0. I'll do this. This is more fun. So if it is true, it'll store true. If it is false, it'll store false. And ultimately I'll return the result. Okay, any compiler errors within this? No, not whatsoever. Let's check with this initial case as well, where we have 101, and for just the sake of understanding, I'll tell you how we are processing. So I'll just add system.out.println and understanding running number. So it will go ahead and it will check 0, 1, okay, not this one. Our example was this 0, 1, and the next number was 5. But since we modded this, we have limited the scope of the running number so that it should not exceed the integer value, double value, or float value, anything. The long value. So we have modded it to 0. So it should not go beyond 5. And that's the reason our result was false, false, and true. So I'll remove this println and submit this code for checking upon rest of the test cases. Well, it says accepted and we have passed our test cases condition, and that's cool. We have majority of solution which deals with the same thing. Multiplication by 2 and shifting it by 1 on the left is one and the same thing. Similar goes with this operation. This is the exact thing what we are doing, but this guy has created a primitive array. So the logic is one and the same, the methods are different, the object storage is different. We directly use the array list, and that's how we made it clean. So for more such things, click the video on your right, and I'll see you in the next one.